On page 217, we have 5 different types of functions. The first one is an exponential growth model. We can see that it's increasing, the exponent is positive, so that is why it's an exponential growth. Did you get that, yes or no? The next graph to the right of that is decay. The reason why that is decay is because the exponent is negative. Do we understand that, yes or no? The next one is called the Gaussian model. Y is equal to A e to the negative x minus b quantity squared divided by c. This is going to be your bell-shaped curve. Remember whenever we're talking about your average IQ, the average ACT, the average SAT scores? Yes? You ever heard 1 or 2 standard deviations away? 1 or 2 standard deviations that they're talking about, that is going to be your IQ. That's going to be your lovely Gaussian model. Okay? It literally looks like a bell-shaped curve. What am I talking about? Those are your standard deviations. This is the normal IQ. This would be the average score. Does that make sense? All the population takes it. The average score would be the highest one. Do we understand that? Outside of those lines would be your outliers. Those would not be your standards. Okay. Now, the next one would be called the logistics model. The logistics model, something that looks like that. The logistics model is a pretty cool function. Basically, what it's used for is going to be kind of like the spread of a virus, sickness, anything like that, where you can see all of a sudden it really increases and just stays there and then levels off. Nobody else gets sick. It's just done. Because obviously, if it was a bunch of people got sick, it would be like Ebola, and it would be like quite obviously. Okay? Okay? Now, those are the functions that we're going to be talking about. If you get your books back to page 224, problems 1 through 6, page 224, page 224.
One more time.
I don't understand how logistic growth model can correlate any equation. How would you do a find that?
We're going to talk about this tomorrow. How would people find that out there?
Kind of like they're just looking at the equation. Oh, that's a logistic model. You know, it's got e to the negative 5x and all this crazy stuff.
You're not actually going to be finding it. It'll be given to you in the scenarios that we were using. You're not going to be finding it. But I can understand what you're saying. Okay, page 224. Problems 1 through 6, it says match the function with its graph. The graphs are labeled A, B, C, D, E, and F. And basically all you have to do is say look at the functions and say which one does it match to. So you're going to be flipping back and forth to page 217 and 224 to match the graphs. Do we understand that? That's pretty simple. Agree?
Agree.
Okay. Now let's go to the meat and potatoes section of this nice homework, which is the lovely little PERT formula. Problems 7 through 15 or 14 say 7 through 14 complete the table for a savings account in which interest is compounded continuously. If interest is compounded continuously, we're on page 182. Those 2 formulas at the bottom on page 182, you guys already have them. The PERT formula is compounded continuously, and then the P times 1 plus R over N raised to the NT is going to be when it's compounded quarterly, annually, biannually, and things of that nature. Do we understand that, yes or no? Today we're doing all continuously compounded, which means we're using nothing but the PERT formula. Now, A is your balance. P is how much money you invested. We already know this. E is a normal number. It's irrational, though, which is why it's kind of funky. R is going to be your rate. What do I have to always do with my rate? I have to make it into a decimal. They give it to you as a percentage. You have to move it as a decimal. And the last one is T, which is going to be time. You guys have written this down, I don't know how many times already this year. True statement? Okay? If you wrote it down again, that means you're committing it to memory. That's wonderful. Now, we're using this formula. Let's talk about doubling our money and tripling our money. If I'm doubling my money, yet I have no idea how much money I'm using or I'm putting in, how do I know how to double? Well, my formula is A is equal to PERT. Right? P is my principal. I want my principal to be doubled. So what's my A going to be? 2P, right? What happens to P's? They cancel out and I have 2 is equal to e to the RT. This is a formula to double my money. This is a formula to double my money. Do we understand that? Now what if I want to triple my money?
You don't have any.
If I want to triple my money, what does A turn into? 3P. Do you want to have the P's? They cancel out, so I actually have 3 is equal to e to the RT. That, what?
How would you have 3 equal to that?
Well, this right here, you're not going to know. It's talking about how long it's going to take. Because in this case, your principal doesn't matter. I want to know how long it's going to take me to double my money or triple my money. Because I pretty much know how much money I'm going to give somebody, but I want to know how long it's going to take me to double or triple my money. Does that make sense? So this is whenever you're looking for T. So maybe we should put that down here. Okay, just so that we're aware of that. So when we're looking for our time, how long it's going to take us to double or triple our money.
Can you do one?
Yeah, I'm over. Okay, we all good on this so far? Okay, we're going to do number 8 together. What this is basically just filling out the table. Okay, you guys have to fill out the table and you have to fill out everything that it's asking for. And this, they're giving you our initial investment. What's another name for an initial investment? P. Okay, they're giving you P. This is P. The rate, well, that's the same thing as your rate. Double. Well, in the book it says time to double. Whenever we're doubling something, we're looking for the time it takes to double it. And then they also have the amount of money that's in your account after 10 years. They give you the time, so now you're looking for the money. Does that make sense? Now, I am given the P value, which is 20%, and I'm also given the rate, which is 10.5%. Is that a good return rate, interest rate, or is that a bad interest rate? It's an amazing interest rate. I will take that interest rate any day. I would be jumping up and down for joy.
Most banks like 3%.
Most banks are 2%. And we're going to do problems just to show you what 2% really is.
Yeah, we're under time.
Double. Dual. Now, what do I want to find first? Time to double or the amount of money that's going to be in my bank account after 10 years? Time to double? Okay. So if we want to find the time to double, I'm going to use my double formula, which is going to be 2 is equal to e to the RT. And we already talked about why it's 2 is equal to e to the RT, right? I know what my P is here. I know it's $20,000, right? So how much money am I looking for it to be in my account? If I started with 20,000, I'm looking for 40,000 at this time, which I'm going to find. Do y'all understand that? So how do I find this? Well, I need to plug in what my R is. My R is going to be 0.105 T. T, I don't know. So how do I solve this for T? What do I do? Yeah, but that's not going to help me solve it. I need to solve this equation. 2 is equal to e to the point. I have to take the natural log of both sides because t is in the exponent position. So in order to get that out of the exponent position, I have to take the natural log of both sides because when I do that, the natural log and e cancel out, and I'm left with the natural log of 2 is equal to 0.105 t. Which, by the way, Alec, you got 100% on the test on Friday. Trish, you missed 1. And those were magnificent scores. Excellent job.
Just like 20.
Now, if I divide both sides by 0.105, how long does it take for my money to double at an interest rate of 10.5%?
$6.6014.
6.6 years. Well, that's pretty darn good. How many people in here, if you had $20,000, easily want to give that away to a bank with an interest rate of 10.5% to get $40,000 in 6 years? Okay? That is great. Agree? That's your college education right there, okay? Now, that means this is what goes right here, it's 6.6 years. Now, how do I find the amount of money that's in my bank account after 10 years? Well, what do? I have to do purge. $20,000 is how much I have. E is a number, R is 0.105, and what's T? 10. So you simply plug that into your calculator. What do you get when you plug that number into your calculator? $57,153. So after how much time?
10 years.
After 10 years, there's $57,153. Now, does that make sense? Well, think about the calculation that you just did. The calculation before that said the time it takes to double your money is going to be 6.6 years. Well, my initial investment was $20,000, so 6 years later, I'm going to have $40,000 in my bank account. And give it another 4 years, would I have about $57,000 in there? Oh, that makes a great deal of me. I'm happy with that. Do we understand that? Yes or no? Okay, let's do it all over again. Number 14.
Well, with interest, wouldn't, like, let's say you put like 20,000 and you get 10% interest, wouldn't after each year, interest be paid for how much interest, like how much money is put in? You know what I mean? Like, let's say 10% of interest is 20,000, let's say it adds like, I don't know how much it adds, like 21,000. Then wouldn't it take 10% of 21,000 and then it just keep going up, like, so it wouldn't be 40,000 a year.
Compounded continuously means it's compounded and taking the next value, then you compound that, then the next value compound.
So that's just if you keep the initial amount.
Okay, so 14. Same thing here. Still got to fill out the chart. P is what? We don't know. R is 2%. Why did I make that sound?
Crappy.
Because it's miserable. We don't want that. Now, how many of you in here have savings accounts? Okay. Are they in banks around here?
Yes.
Okay. They're in banks in Ohio, in this region, within a 30-mile radius or 40-mile radius. What do you think your interest rates are probably going to be? 2 to 3% if you're lucky. Okay. Maybe 4% pushing it. Okay. Some of them probably aren't even that high. Now, there's what we call a money market account. Money market accounts are basically where they're not a local bank. They're an online bank. Okay. And everything is done online, but you have 5%, 7% interest rate on those bank accounts, which are wonderful. However, it has a 24-hour wait before you can get any of your money out. So you have to request it, which would be fine for ages like you are. But let's say if you're an adult, but you want to put all of your money into that type of an account. Why? Because what happens if there's an emergency and you need it right now, and you can't wait 24 hours to get that out of the bank? That's why you put as much as you can free up, put in there, and get that nice 5 to 7% interest rate, knowing that you can easily use that money in 24 hours if you needed to, and then that other chunk of change that you have, you're going to keep locally so that you are able to have access to it readily and immediately if you need it. Okay? And some people just keep their checking accounts higher and just put the savings account in there so that they don't have to worry about that. Okay? Now, let's continue to go on with this. We need this to double, and we need to find my interest rate, my principal, sorry. So which one do you want to find first? Principal? Or how much time it takes to double? Principal. So what do I have to do whenever I need to find my principal? Yes, but what formula I have to use is PERT. So I know, I don't know P. I don't know P. What do I know? I know my rate. My rate is 2%, so that's going to be 0.02. What else do I not know, or do I know, I should say? The time is 10 years. Okay, well, what else? The amount of money in my account after 10 years is $2,000. So how do I find my P? Well, what do I do? just divide, because e to the 0.02 times 10 is just e to the 0.2, and it's just a number, correct? So if I divide both sides by this, what is p? $1,637.46. Now, let's talk about that a moment. Really look at that. It's right. It's just like that. Well, your initial investment is going to be $1,637.46.
After 10 years.
And after 10 years, at a 2% interest rate, we're talking pennies. That's all
Only people get more than that.
After 10 years, you are going to get $2,000. Do you understand why whenever you put your money into a savings account, you really need to look at the interest rate that you have? Okay? When you get a big chunk of change, now is the time when you guys, if you're working a summer job, if you get like $2,000 or $3,000 in the summertime, how many of you get $2,000 or $3,000 in the summertime? Okay? If you can afford to take that money and not use it for college right away, and dump it into an account somewhere and invest it in the medium, you can have a nice chunk of change. CD is not going to work. Online account isn't going to be risky enough. An online, are you talking the online 5 to 7% interest rate that I was talking about? That is like a checking account. Okay, it's going to give you more interest, but you want to go put it into, investment somehow. Really want to do that, like a hedgehog fund, some way. Like an IRA or Roth IRA, something like that. That gives you something for your money to put in there, and it's going to gain. Like what you're doing is you're buying part of a company. Yeah. You're buying part of a company, you're getting the stock market. Okay? That's what you want to do, because if you can afford to put $2,000 or $3,000 in, by the time you guys are 25, you guys have a little bit of money that you can play with if you need to. Over a 10-year period, you always gain on your money. You're going to lose, but over 10 years, you will gain. There's only been one time in the stock market where it's not gained. Yep. Now, how do I find the times double?
2 equals.
2 is equal to e to the RT. R is 0.02. How do I find this? Take the natural log. So the natural log of 2 is equal to t. Oops, sorry. 0.02t. And how do I solve that? Divide. So I have the natural log of 2 divided by 0.02 is equal to t. And how long does it take to double my money?
34.6.
That's depressing. That's extremely depressing.
Or 0.7.
Do we understand that? 34.6 years.
So not time to $4,000 time.
Uh-huh. Well, 32 pounds. But your initial was 16. Okay. Now, 15 and 16 says complete the table for the time t necessary for p dollars to triple if the interest rate is compounded continuously. Number 16, it says complete the table for the time necessary for p dollars to triple if the interest is compounded annually. Do we understand that? So continuously you're using per, annually you're using p times quantity 1 plus r over n raised to the n t. Page 182. Do we understand that? Now all you have to do is fill out the table. Do we understand that? Keeping in mind, it says that it wants to triple. So if it wants to triple, I am using this formula. Agree? Which means the natural log of 3 is equal to RT. Right? What am I going to solve for here? R or T? They give us R. What I need to find is T. So if I divide by R, the natural log of 3 divided by your rate is equal to your time. In other words, I'm going to have the natural log of 3 divided by x is equal to y. That's the function you put in your graphing calculator. Why would you put that function in your graphing calculator? To create the table, because do you want to plug and chug 5 or 6 times? I don't. I want to use the table so I can just copy it out of the table, right? And then you would actually change your starting point and ending point to be what? It's 2%, 4%, 6%. So if I'm at a 2% rate, what is that actually? 0.02. So you're starting at 0.02, and then you're going to go increment by 0.02. Do we understand that?
You're just gonna put that in.
And you're just going to put that in, and you're going to create the table. Any questions over what I want out of you tonight? Tomorrow you guys will have a worksheet to do. Are we good? Excellent.
So today I woke up and I got all my stuff together except I couldn't find my black.
So